Hello all. Welcome to the video lecture series on Unit 1 of Computer Networks and Security. The topics covered in the Part 1 of Unit 1 are Introduction to Networks, which includes need and usage, network criteria, types of the networks, and types of the link configurations. Network topologies, layered architecture OSI model, functionalities of each layer, and some more information which is relevant. In this very first session, we are going to discuss the first point given on the slide. So let us now begin. What is the need of the network? The question is absurd enough because in each and everything that we do nowadays is using some network. May it be sending emails or having sessions on platforms like Zoom or Teams as we are doing right now, or even playing online games, watching movies, downloading songs, sending WhatsApp messages, you name it and we have it. The purpose of studying this subject is getting the knowledge of what runs behind and how does it operate. Today, we do realize that anyone, and I mean anyone, can use the technology, can run various apps also. But as an engineer, we should know how does it work and how is it designed. And hence we are here to learn this subject. With this discussion on usage of the networks, now let us proceed to the need of the network. What a computer network is used for? Sharing of resources, soft resources like sharing the information, or hard resources like sharing a printer. For both, we need the devices to be connected on the network. And then there is a list where we need to have a network. In gaming, entertainment, multimedia, applications, banking, remote access, and the list goes on. Okay, now once we have a network, we also need to test the network. And the criteria for this testing are network performance, reliability, and security. Now let me elaborate on this more. We all know that the network has to be reliable, the network has to be secure, and network should perform as expected. So which are the parameters which are considered while testing these criteria that we are going to see now? So performance of a network is dependent on time it takes. In other words, you can call it as a speed of the network. Then another one is throughput and delay. Throughput is nothing but how much data is delivered successfully with respect to the sent data. Please understand, each and every parameter we are going to study in detail in later stages. Today we are just having introduction of these parameters. And then third one is the efficient use of parameters in the routing process. Routing is the process of sending or carrying the data packet from one location to another location. So these are the parameters which come under performance of the network. Then comes reliability. When do we call the network or a system a reliable one? It should be accurate. That means the data delivery along with the speed, it has to be error-free or it has to be accurate. The second parameter is frequency in system failure. In the telecommunication, it is called as MTBF, that is mean time between failures. How many times it is failing, how many times the whole system is failing, its frequency is the measure of reliability. MTBF has to be as minimum as possible. And time to recover from failure. Suppose now the one's system is failed. How much time is required to gain the complete operating system again, to obtain the operating system again with its full capacity. It is known as MTTR, mean time to repair. This also has to be very less. And then the network has to be robust. It cannot be sensitive to multiple parameters. With all these parameters, we will call the network reliable one. And finally, we come to the security part, which is obviously protection from unauthorized access. And if the system fails, there have to be a procedure to recover the complete data. Then only the system will be known as a secured system. So a good network has to perform well, must be reliable, and must be secured. Now the next parameter is type of links. We all know what a point-to-point link is. As you can see on your screens, the upper diagram shows you point-to-point link. There are two stations and there is a link running in between. And this link is dedicated for the communication between only these two stations. So we call it as point-to-point link. Whereas the lower diagram shows multi-point links, where there is one server, which we call it as mainframe as well, and there are various stations. All these stations are connected to a single link, and in turn, it is connected to the mainframe through the same link. This is known as shared link, and this communication is known as multi-point communication. We will be mostly interested in multi-point communication because we need to learn various protocols where the stations share the resources, share the links, share the media, or share the channel, and then it will be decided who should send, how much to send, how to avoid the collision if it is if the collision happens, how to detect it, and so on. So I hope the types of link is clear: point to point and multi-point. Then we come to the classification of the networks on various bases. There are various types of networks, and those networks can be classified based on whether the transmission media used is UTP, coaxial cables, fiber optic cables, and so on, or the network is a wireless network. Then there is second criteria, which is network size. Depending on the size of the network, it can be classified as LAN, MAN, and WAN, which we are going to study shortly in this session only. The third parameter, third criteria that can be considered is management method. Whether the stations, workstations are communicating on peer-to-peer basis or there is a client-server configuration. And then finally, the classification can be done based on the topology of the network. That means physically how the stations are connected to one another. This topology part we are going to study in the next session. Now, we will concentrate on this point, classification of networks based on network size. So first classification, first category is local area network, that is LAN. We all have heard about this word. We always say that the stations are on the same LAN or on the different LAN. So what this local area network means? Local area network is a collection of stations in a limited area, probably a single building, or we can have multiple building LAN also. As you can see in the diagram, there is a backbone and to which various smaller group of stations are connected. This also forms a LAN. Now this reminds me of the LAN that our institute has. We at PICT have a LAN structure which we are going to study in detail, where you will find which topologies are used, what is connected to router, which stations are connected to switches, and why. So this is the idea of a LAN. LAN is restricted to one building or multiple building, or you can say one campus. Then the next type of network is metropolitan area network, that is MAN. The range of MAN is little bit more than LAN, it comprises of the area of one complete city or a smaller town. Or in our case also, we can say that smaller area, but more than the campus. So this is called as metropolitan area network. And the third one is wide area network, WAN, which is all over the world. So across various countries, if you have a single network, we say that all the stations are on the WAN. Now, the next diagram should give you an idea about how the internet works. What is an internet? So internet is collection of various LANs connected to MANs or WANs directly. So this whole network is called as internetwork, which we abbreviate as internet. So now we have come to the end of first video or first session. Let us go through sample questions which you are supposed to answer. Categorize the following examples in simplex, half duplex and full duplex. Telephonic conversation, whether it is simplex, half duplex or full duplex. Letter, email, listening to radio stations, WhatsApp messages. The second question is, do you think that the speed of communication is always a priority when it comes to determine network performance? Please think over these two questions and then we will meet for the next session on network topologies. Thank you.